The complex number u is given by u equals to 8 minus 15i. Showing all necessary working, find the two square roots of u. Two square roots of u. Give answers in form of a plus ib, where the numbers a and b are real and exact. Okay, we know in quadratic equation, if we have square root of a function, a quadratic function, then you have two roots. Okay, you have two roots. So I don't know what are those two roots, but I'm going to label each root as a plus bi and a plus bi. Okay, because I know two roots, these two roots multiply, it will give you 8 minus 15i. Okay, so this is the first thing that you have to understand. Now let's expand this. So when you expand, you get a square plus abi, so 2abi, and then plus b square and I square, and this is equal to 8 minus 15i. So I can simplify further. So what do I have? So I have a square plus b square plus 2abi, and okay, so this is bi, ab square I square plus 2abi equals to 8 minus 15i, and I know I square equals to -1, so a square plus b square times by -1 plus 2abi equals to 8 minus 15i. So a square minus b square plus 2abi equals to 8 minus 15i. Okay, so let's split this. Okay, let's split this. So we have a square minus b square, so and then we have 2abi. So if you look at it, one is the real part and the other one is the imaginary part. So I'm going to equate that a square minus b square with 8. Okay, and then I'm going to equate 2abi with -15. Okay, so I can discard the I, so 2ab equals to -15. So this is number 2, this is number 1. Okay, now let's solve both of them. Okay, so to solve this, so I have 2ab equals to -15, so b equals to -15 over 2a. Okay, sub this into the first equation, so a square minus b is -15 over 2a, and square of that equals to 8. So now let's expand this, see what we are getting. So it is a square minus 225, so -15 times by -15 will give you positive, but since negative is outside, so it's negative over 4a square equals to 8. So make it into single fraction, so we have 4a to the power of 4 minus 225 equals to 8. Okay, sorry, equals to 8 times by 4a square. Okay, so now expand this. 4a to the power of 4 minus, that's 32 a square minus 225, and this is equals to 0. Okay, looks like we can do a quadratic equation, although to the power of 4 we can still do a quadratic equation. So therefore use your calculator to find the fraction. Let's assume that a square equals to let's say a square equals to x, so that'll be 4x square minus 32x minus 225 equals 0. So using calculator, x square equals to 25 over 2. Okay, not x square, x equals to 25 over 2, and x equals to -9 over 2. So therefore we know a square equals to x, so a square equals to 25 over 2 and a square equals to negative 9 over 2, so times this, so 2a square equals to 25, so a equals to 25 over 2, which is square root of that, and a equals to positive and negative 5 over 2 plus minus. Okay, so therefore this is, if this is a, okay, I can discard this. Okay, so because a square, you'll get, we are not looking for a here, so we wouldn't be bothered here because it's a negative number. Okay, so now let's look at what is b. So take a and then sub into b, so b equals to, what is b? B equals negative 15 over 2a, so b equals to negative 15 over 2 times by 5 over 2. Okay, so you have negative 15 divide by, so that's 10 over 2, and this should give me, multiply this, okay, negative 3 over 2, so 2, and if I want to get rid of the third, I can multiply that by 2, so 2, and my final answer here is negative 3 times by 2 over 2 times 2, and the answer is negative 3 over 2. Okay, so that's the answer for the first one. Now when a equals to negative, okay, when a equals to negative 5 over 2, then b equals to negative 15 over 2 times by negative 5 over 2. Okay, negative 5 over 2, so which I can simplify to negative 15 over, that's minus 10 over 2. Okay, minus 10 over 2, and if I simplify that, you get negative negative is positive, so therefore this is, again, it gives you 3 over 2. Okay, so 3 over 2. So therefore, how many values do we have? Okay, so we have a, which is 5 over 2, and from there I have b as negative 3 over 2 I. Okay, that's your first root. Then the second root, or negative 5 over 2, and from there I have got positive 3 over 2 I. Okay, so these are our two values for the roots. On an Argand diagram, shade the region whose points represents complex numbers satisfying both the inequalities z minus 2 minus I modulus that's less than 2. So immediately you should know that's a circle. Okay, and then 0 less than Argand z minus I less than quarter pi, and that's half line. Half line, what is the coordinate? Okay, what is the coordinate? Remember, it's negative I only, so therefore there's no value on your real part, so the coordinate will be 0 and 1. Okay, and the angle is argon z minus I equals to pi over 4. Okay, so let's sketch the diagram. Okay, so you have argon diagram. Okay, circle, what is the coordinate of circle? So negative 2 minus I, so if I put that, so negative and then 2, and should be positive I. Okay, you make sure that we change it to this form, z minus zi, okay, or z1. Okay, make sure you change it to this form. Okay, so when I put it into this form, so we have z minus z1, so we have, it's not negative anymore, you take out the negative, so what's left is 2 plus I. So therefore the coordinate for z1 is, let's say if this is 1, that's 2, that's 3, this is I, and that is 2I, and this is 3I, and that's IM, and this is RE. Okay, so let's draw the circle. So circle radius 2. Okay, that's the radius. Okay, radius 2. Okay, and what is the coordinate? It's, the coordinate is 2 positive 1. Okay, so 2 positive 1 I, so that's where it is, and the radius is 2. So from there we go down, that's negative I, so negative 2I. Okay, and this is negative 1, and let's say that's negative 2. Okay, so now we go down, I'll change the color, so we go down 2 units down, so because of the radius, so we go down to 1 2, so that's the lowest point. Okay, and then we have another 2 points to the left, then another 2 points to the right, and then another 2 points to the left, so it should be one more over here, which is 4. So approximately, this is just a sketch. Okay, so try to draw as accurate as possible, so maybe you get something like that. Okay, somewhat like that. Okay, so that's your circle. Your next line is, what's the next line? It's a half line, so that's z minus I, so therefore the coordinate is 0 1. So where is 0 1? So it's here, that's 0 1. And okay, and remember the angle is pi over 4. Pi over 4 is 45 degrees, so you take 45 degrees from here, which is, so what I can do, somewhere this way. Okay, so this is your argon, pi over 4. Okay, pi over 4. Now on the diagram, the question, once you've drawn this, shade the region whose points represent complex numbers satisfying both inequalities. So less than 2 is inside the circle, and 0 less than z minus I less than 45 degrees. So less than 45 degrees is everything inside, and also less than 2 for the circle. So the blue color region is the region that we wanted, okay, for the answer. So that's your answer for this question. Okay, so if you do step by step, you should be able to get this.